You all are welcome to Nicole's channel. And in this channel, we focus on tutorial videos on topics under mathematics and statistics. Starting with mathematics today, we are going to be looking at a topic, and that topic is binomial theorem. Okay, remember our hashtag, you don't need to be a scholar to get an A. Because this is the handle of my tutorial. Let's continue. Now, in this topic, binomial theorem contains 4 parts. Yes, so we are going to start with the first part, which is part 1. Now, binomial theorem. What is binomial theorem? Binomial theorem is a method of expanding an expression that has been raised to any finite. For example, if I have something like x plus y raised to the power of 4, raised to the power of 2 rather. In this case, we can expand this to, or we can represent this to give x plus y in brackets x plus y. Expanding this with normal arithmetic, you do x times x squared, x times y xy, y times x plus xy, y times y squared, and so on and so forth. But in the case in which you have a very large power, example, we have x plus y raised to the power of 10, using that method is going to be very, very tedious. So instead of using that method, mathematics have provided us a very, very simple method, and that method is called the binomial theorem. Is that understood? Now, it is a formula for finding any power of a binomial without multiplying at all. You don't need to multiply, you just need to follow the steps in which we'll be teaching in this class. Now, example, look at this example. If I have x plus y raised to the power of 4, this x plus y raised to the power of 4, using one of the methods, is to give x raised to the power of 4. Okay, let's clean this. Now, this x raised to the power of 4 is actually x raised to the power of 4, y raised to the power of 0. Is that okay? X raised to the power of 4, y raised to the power of 0. Then the next one is 4x raised to the power of 3, y raised to the power of 1. 6x raised to the power of 2, y raised to the power of 2, plus 4x y raised to the power of 3. Then this y raised to the power of 4 is actually x raised to the power of 0, then y raised to the power of 4. Now, what do we observe from this expansion? The first thing we observe is that each expression is homogeneous in x and y. What does that mean? It means that the sum of the powers of x and y is equal to the what? To the power of the binomial. So in this first, the power of the binomial here is raised to the power of 4. So in this first term, we can see that 4 plus 0 will give us 4, 3 plus 1 will give us 4. In the third term, 2 plus 2 will also give us 4, and so on and so forth. 0 plus 4 will give us what? Will give us 4. Now, the second property we can observe here is that the powers of x are in descending order, and consequently, the powers of y are in ascending order. If you notice, you see we have x. This x is raised to the power of 4 here, x is raised to the power of 3, x is raised to the power of 2, x is raised to the power of 1, x is raised to the power of 0. So it is x is in a descending order of powers. Is that okay? Unlike y, which is ascending. So y is 0 here, y is 1. So 0, 1, 2, 3, 4. Is that okay? Good. The third property we can see is that with the powers arranged this way, the coefficients form a pattern. They form a pattern. And what gave us that pattern? We are going to be using what we call the Pascal Triangle to understand what that pattern is all about. Is that okay? So let's go on to the next slide. Now, basically, this is an example of a Pascal triangle. Is that okay? Now, a Pascal triangle is a triangle that spells out the terms in the binomial theorem. Is that okay? Now, in the first, this is called the 0th term. This is called the first term, the second term, the third, the fourth, and the fifth. Is that okay? So it always starts from the 0, 1, that's 0, 1, 2, 3, 4, 5. Now in the 0th term, we have just 1. In the first term, we have you just put 1, 1. Very, very easy to remember. But in the second term, this is how we do it. This one, you bring it here. So 1 comes to this side. So 1, you bring it here. Then you do 1 plus 1. 1 plus 1 is what? It's 2, right? So we get this 2. Then this remaining one, you bring it here. Very, very simple. So you can do it offhand. without checking any material. Now, this one also, you bring the 1 here, very simple. Then you say 1 plus 2 is equals to what? 3. Then this 2 plus 1 is also equals to 3. Then this one, we bring it here. Is that okay? Now, also to get this fourth term, what do? We bring this one here. Then we say 1 plus 3. 1 plus 3 is what? Is 4. 3 plus 3 is what? 3 plus 3 is 6. 3 plus 1 is 4. And this one, we bring it there. And that's all. Very simple. And the last one, the same thing. This one, we bring it here. 1 plus 4 is what? Is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And 1, we bring it here. So that's how to get the terms in our Pascal triangle. Now let's relate this to an algebraic expression in which we have, or a binomial in which we have power. Example, if we have x plus y raised to the power of 0. When you have x plus y raised to the power of 0, you know that it is the zeroth term, so it only contains only one term, and that's why we have 1 here. You understand? Yes. When you have x plus y raised to the power of 1, you know it contains 0 and 1. Is that okay? So it contains 1, and this one, it must have what? 1 1 here. So it will have 1x plus 1 y. Is that okay? You pick the first term, you pick the second term. Is that okay? Now, when you have x plus y raised to the power of 2, x plus y raised to the power of 2, the first thing you need to know is that when we have x plus y raised to the power of 2, the first thing you need to know is that x decreases in power. So x carries 2 first, because we have 2 as a binomial here. As a binomial here. Then y, you carry what? You carry 0, right? Plus, then x reduces, right? To give 1. Y increases from 0 to give what? To give 1. Is that okay? Plus, x decreases from 1 to what? To 0, which is the last. And y increases from 1 to what? 2. Is that okay? If you notice, the addition of all the powers of this term, of both x and y, gives 2. That's 2 plus 0 is 2. 1 plus 1 is 2. 0 plus 2 is 2. If yours is giving you more than 2, sorry, you are wrong. Now, simplifying this, we have x squared plus x1, x raised to the power of 1, y raised to the power of 1 will give us xy, plus x raised to the power of 0 is 1, so it will give us what? Y squared. Is that okay? Now, this is the first thing you ought to do first before getting your terms. Now, when you have x plus y raised to the power of 2, then you draw your Pascal triangle, and your Pascal triangle is stop at the second term. And you can see in the second term we have 1 2 1, meaning that this x squared will have a coefficient of what? Of 1. We don't need to write 1 there, so we write x squared. This second term will have a coefficient of what? Of 2. So for xy, what do we have? We have plus 2xy. I'm sure we are getting. Then this y squared will have a coefficient of what? Of 1. So we have here, we have y squared. Do we understand? So in this case, we successfully expanded x plus y raised to the power of 2 to give x squared plus 2xy plus y squared. Now let's do assuming we have something like x plus y raised to the power of 4. When you have something like x plus y raised to the power of 4, now you start with x. So you have x raised to the power of 4, y raised to the power of 0. Is that okay? So x decreases to x raised to the power of 3, y raised to the power, y increases to 1. Is that okay? Plus x decreases to 2, y increases to 2, plus x decreases to 1, y increases to 3, plus x decreases to 0, while y increases to 4. Is that okay? And we stop here. Now, having this, you notice that the addition of all their powers is equal to 4. Is that okay? Now, simplifying this, y raised to the power of 0 is 1. So we have x raised to the power of 4, plus, in this case, we have x raised to the power of 3, y, plus, here we have x raised to the power of 2, y squared. Here we have x, okay, let's write it to xy cubed. And here x raised to the power of 0 is 1, so we have y raised to the power of 4. I'm sure we are getting. Now, then you start introducing your terms. For x plus y raised to the power of 4, you know you are stopping this 0, this 1, this 2, this 3, and this 4. So this is what you're actually using. Is that okay? Now, the first one says that the first coefficient is what? Is 1. So for x raised to the power of 4, what do we write? Is 1, right? So we don't need to write 1. So we just write x raised to the power of 4, like we did here. Okay, let's follow what we did here. X raised to the power of 4. The second term is what? X cubed y, right? Which is what we have here, s cubed y. And what is the term here? The term here is 4. So you just put your 4. The next term is 6. So you just put your 6x squared y squared. The next term is your what? Is your 4. So you put your 4xy cubed. And the last term is your 1. Is that okay? That's the last coefficient of your term is your 1. And 1 times y raised to the power of 4 is y raised to the power of 4. I'm sure we understand the expansion of um, of expressions using binomial theorem, or rather using Pascal triangle. So now let's move on to our next slide. So okay, now methods of getting the binomial theorem of an expression. Now the first method which we just discussed is the method or approach of getting the binomial theorem of an expression is by using the Pascal triangle, which I've just explained. Now, example, let's solve a question. If I have x minus y raised to the power of 5, I can write this x minus 5, x minus y to be x minus plus y raised to the power of what? Raised to the power of 5. Is that okay? So, and that's what I have, the x plus minus y raised to the power of 5. If you open this bracket and you have minus times plus, it will give us what? It will give us minus. So we haven't actually changed. Now, having this, remember what I said. The first term here is your x. The second term is your what? Is your minus y. And remember, your x carry, the first thing is that your x carries 5 and the minus y carries 0. Is that okay? Then your x start reducing in power and your minus y, that's your second term, starts increasing in power. So if we have x raised to the power of 5, the next term will be x raised to the power of 4 minus y raised to the power of 1. The next term will be x raised to the power of 3 minus y raised to the power of 2. And the next one will be x raised to the power of 2 minus y raised to the power of 3, x raised to the power of 1 minus y raised to the power of 4. You see, x is decreasing, y minus y, that's your second term, is increasing. And from 1, it goes to x raised to the power of 0. This is minus y raised to the power of 5. It's a mistake. Minus y raised to the power of 5. Is that understood? Now, after you've done this, the first thing is to do what I just said. Now, the second step is to get the coefficient of your terms by drawing your Pascal triangle. So in your rock paper or whatever, you draw your Pascal triangle. You know this 0, this 1, this 2, this 3, this 4, and this your 5. Is that okay? So you know that x raised to the power of 5 minus y will carry the coefficient of what? Of 1. Is that understood? Now the second term will carry the coefficient of what? Of 5, according to our Pascal triangle. The third one will carry the coefficient of what? Of 10. Is that okay? And that's why we have 10 here. Is that okay? The fourth one will carry the coefficient of 10, and that's why we also have 10 here. The fifth one will carry the coefficient of what? Of 5. That's why we have 5 here. And the last one will carry the coefficient of 1. That's why we have 1. Is that understood? Now, what do we now do now? Is simplify this. We know that anything raised to the power of 0 is 1. So minus y raised to the power of 0 is what? Is 1. 1 times x raised to the power of 5 times 1 will give us what? Will give us x raised to the power of 5. Is that okay? Now, plus times this minus will give us what? Will give us minus. So we have 5x raised to the power of 4, y raised to the power of 1. Is that okay? Now, okay, this is a mistake. Okay. Okay, it's not okay. Let's continue. There is no mistake here. Now, minus y squared means minus y times minus y. Minus minus is what? Is plus. Y times y is what? Is y squared, right? So 10. So that's why we have 10x cubed y squared. Is that understood? Now, look at this minus here. Minus y raised to the power of 3 is minus y cubed. So that minus times this your plus will give us what? Will give us minus. Is that okay? And that's why we have 10x squared y cubed. Now the same thing here, minus y raised to the power of 4 is y raised to the power of 4 because the minus cancels each other. Are you following me, please? Okay, the minus cancels each other. So this is what I'm saying, minus y times minus y times minus y. We have 3, right? So minus minus is plus, plus minus is what? Is minus. So we have minus y cube. And that's why in this case we have minus y cube here. So minus y cube minus times this plus give us minus. Is that okay? But when you have So when we have minus y times minus, that's minus y raised to the power of 4. Minus minus is plus, plus minus is minus, minus is what is plus. So everything gives us plus y raised to the power of 4. That is why in this case we have plus, we have a positive sign here. Is that okay? So we have plus 5x y raised to the power of 4. Then this is minus y raised to the power of 5. And you know minus y raised to the power of 5 will give us minus y raised to the power of 5. So plus times this minus will give us what? Will give us minus y raised to the power of 5. And we know that x raised to the power of 0 is what? Is 1. 1 times 1 is what? Is 1. So this is generally how to find how to expand a binomial using the Pascal triangle. So I'm sure we all get this. Now, methods, under methods of getting the binomial theorem of an expansion. Okay, the second method is, and the most efficient, and the one we will be concentrating in this tutorial, is the idea of combination. Why are we using the idea of combination? Because it is the most efficient in terms of speed. Yes, it is the most efficient in terms of speed and accuracy. So you get the accurate answer and you be also fast. Now, generally, this is where we are going to stop in this part 1. Okay, so that the video will not be tedious in nature, will not be too long. So you are going to stop here. So make sure you subscribe to our channel to get more videos. That's to check to get the part 2, part 3, and so on and so forth. Now, the binomial theorem for all values of a and b, provided n is a positive integer. N is that means the raised to power of your expression must be positive. Is that okay? It's given by a plus b raised to the power of n. Now, before I explain this expansion, let's first understand what the idea of combination is. Is that okay? The idea of combination is when we say combination, what comes to our mind is n combination r. Is that okay? N combination r. And n combination r gives us something like n factorial over n minus r factorial, then r factorial. What does that mean? Example, if I have something like 5 combination 2. Is that okay? If I have something like 5 combination 2, what will I have? 5 factorial over, that's 5 minus 2 factorial, then 2 factorial. Is that okay? Because the 5 is n and the r is equal to 2. So we just represent anywhere we see n, we put 5, anywhere we see r, we put 2. Is that okay? Now, what will this give us? This will give us 5 factorial. That's solving this will give us 5 factorial. 5 minus 2 is what? Is 3 factorial. Is that okay? And 2 factorial. Is that understood? What does factorial mean? If I say 5 factorial, I mean 5 times 4 times 3 times 2 times 1. Is that okay? Exactly. The same thing with 3 factorial. 3 factorial will be 3 times 2 times 1. 2 factorial will be 2 times 1. So if I say 5 times 4 times 3 factorial over 3 factorial times 2 factorial is 2 times 1, right? This 3 factorial cancels this 3 factorial. What remains? 5 times 4, right? 2 here 1, 2 here 4 is what? Is 2. 5 times 2 is equals to what? Is 10, right? 1 times 1 is what? Is 1. So 10 divided by 1 is what? Is 10. Is that understood? So 5 combination 2 will give us an answer of what? Of 10. So this is the general knowledge on factorial. Is that understood? And we are going to be applying it very immensely in this tutorial. Is that okay? So a plus b raised to the power of n, expanding it will give us n. Is that okay? N combination 0. The r is at 0 first. N combination 0. Then the first term, which is a, carries that n. The second term carries the 0. Is that okay? Plus, then this 0 increases to 1 to give n combination 1. Then a becomes n minus 1. Is that understood? Then b carries 1. Plus n combination 2, a becomes n minus 2, the n minus r. Is that okay? So the n minus 2 and b carries 2. The same thing with this n combination 3 will give us a raised to the power of n minus 3, then b carries 3. Is that okay? Or n combination 4 will also give us a n minus 4. That's a raised to the power of n minus 4, b raised to the power of 4, and so on and so forth. Is that understood? Now, what we also need to know before we come to the end of this class is that our n factorial will give us this. N factorial is the same as n into bracket n minus 1 into bracket n minus 2 into bracket n minus 3, and so on and so forth. Okay, so this brings us to the end of part 1 of binomial theorem. What have we learned? We've learned the meaning of binomial theorem. We've learned the different methods of, or rather the two methods of getting the expansion of a binomial. Is that okay? And the first method we said is the Pascal triangle. The second method is the idea of combinations. So in our next class, by God's grace, we'll be looking at examples under the idea of combination. So thank you for listening. Thank you for watching. Make sure you subscribe to this channel to get more videos. Make sure you like and comment. Thank you very much. May God bless you.